Geometry 10.7, page 505. These are called tessellations. What a wonderful word, tessellations. What this is talking about, if you look at the pictures in this book, it's taking polygon shapes and putting them together to form a pattern that continues and covers up every piece of the area being covered. Okay? It starts off, tessellation is a plane. Tessellation of a planar region is a covering of that region with one or more figures so there are no overlaps or gaps. All these pictures up here show a pattern that covers the entire region, okay? An example 1, determine whether each regular polygon can be used to create a regular tessellation of a plane. So what you do here is in a triangle, this is how it's done. Kind of did a bunch of it for you. Triangle has 3 sides. Interior angle is 60, exterior angle is 120. If you take that interior angle and divide it, 360, divide that, if it comes out even, that means we can use it. Right here, a square, a rectangle. It's 90 degrees inside, 90 degrees outside. 360 divided by 90 is 4. That's an even number. That's a non-decimal, non-fraction. That's a yes. A pentagon has 5. Exterior is 72, interior is 108. So we take 360 divided by 108, 3.3 repeated. That will not. You cannot use polygons, regular polygons, all put together. They will not cover everything. Hexagon, 120. Divide comes out 3. Yes, you can use hexagons. Octagon comes out there. Nonagon, that's 9 sides here. Decagon, 10 sides here. So this will not, this will not, this will not, this will not. This, and this are the 3 that form tessellations, regular tessellations, where I'm using all the same polygon. If I take any 3 triangles, any 3, right, acute, obtuse, and put them together, I can always fit them to form a pattern that covers everything. You know, flip them around, turn them over, all that, but it's the same triangle. Any rectangle or square can be used to cover an entire object. Any hexagon, regular hexagon, 6 sides will always fit together. Okay? So now there's a couple words. Number 1 is regular. That's just using one kind of the same regular polygon. A semi-regular uses 2 types of polygons. This is a semi-regular tessellation here. It's using triangles and squares. It's the same triangle everywhere, and it's the same square. And if I keep putting them together, it will always cover the object. Irregular is when it's not regular, and it's not, semi-regular. Wrong word here. I'm not even going to try to draw some of these. If you look in your book, irregular. Let's see, number 13. That's a great pattern, but it's non-regular polygons in there. If your eyes are close enough to see that, I can't hardly see it. But that's non-regular. One of the polygons used looks like this. That's not a regular polygon. There's nothing wrong with it, but I'm using the same thing over and over again, but it's not regular, and it's not semi-regular, therefore it's irregular. There's no law against it, just makes it irregular. Now, if we have a regular or a semi-regular tessellation, what we can do is find I think they call it the order. Let's see, what's that called? Use the numbering system to classify each semi-regular tessellation. Okay, so I took one of them. This is number 5. What's talking about is if you take a vertex anywhere within here, not on the outside, but anywhere within here, we'll use that one right there. And we're going to start with right here, and we're going to work our way around in a circle. If I look at this, that one has 3 sides. That's one. I go to here, that one has, number 2, that one has 3 sides. I go here, that one has 3 sides. I'm going around. Now this one down here has 4 sides, and this one here has 4 sides. So anytime I choose, if I started right here, okay, I'd have 3, 3, 3, 4, 4. We usually put the small side, start with them, and then go to the big ones. This is the order. This is what it's called. It's a 3, 3, 3, 4, 4. When I start somewhere, I just go around a circle. Okay, these are really kind of fun to do. If you look at number 9, okay, and you choose one of those interiors there, those things on the outside, the big things are not circles. Those are dodecagons, 12-sided. So if I take an interior point and I go to one of those, I have 12. Okay, let's start with the small one. We go to the triangle in the middle, that's 3. Okay, and then I go to a 12, 12, and I'm back to the triangle, 3. Okay, on number 10, okay, you do walk your way around it. On number 11, number 12, number 16, number 15. Okay, if it's I'm sorry, what's the word? Irregular, you don't have a numbering system on it. Okay, you don't have a numbering system on it. And so you just have to answer the questions. Number 1, can you use 1, 2, 3, 4? And I've kind of already told you that. Number 5, write out the numbering system for it. 6, 7, 8, 9, 10. On 11, determine whether it is regular, semi-regular, or irregular, and use the numbering system of the regular or semi-regular. Okay, if it's irregular, you just write irregular. All right? So you're going to do on here, you're going to do 1 through 16. Hi. Then you're going to turn it over and you're going to go, let's see, 20 through 26. And then you're going to do, 20 through 29. I'm sorry. Sorry, 20 through 29. There's not a lot of math. There's a lot of drawing on here. And please, try to make your drawings as accurate as possible. Don't just, try to use some logic in your drawings, okay?